Hi STEM First students. In this video brought to you by the Student Leadership Board, I'm going to be going over an advanced graphing analysis, more advanced than the basic graphing analysis that I had earlier. And so here we're going to be going over things like how to make trend lines, error bars, and p-values. And so this is to accompany the data analysis workshop that we did earlier in the school year. And this is one of the demonstrations that we did during the workshop that we thought we should bring to other students who are not able to make that workshop. All right, so let's get started. So here we have some data. We have time and two conditions. So in this case, it's growing bacteria on some plates or something like that. And so we have condition 1 and condition 2. Awesome. So first, to make a chart, I think a scatter plot would be kind of good for this. So I want to make a scatter plot. So I'll go to charts and then scatter. But right now it's blank because I haven't put in any of the data. So here I need to select the data. And so you can put in a data chart range, but what I like to do is I like to put in the legend series individually first. So here we have two. We have condition 1 and condition 2. So here I'm going to first put in the legend series one by one. The series name here is condition 1. The series X values are right here. And then the series Y values are here. Condition 1. So if you can just highlight the cells like this in Excel in order to kind of input that immediately into the graph. And there's condition 1 and it's labeled condition 1. Awesome. Now I'm just going to put in condition 2. So it's called condition 2. The X values are the same time. And then the Y values are right here. All right, awesome. Now you can see that on the bottom we have 0 through 35. Which is good because we put in time and hours, right? So we just need to make sure that those match up. And then here we have from 1062 to 0. So that's pretty good. Okay, now I'm done putting in all the data. So this is like a nice, starting to look like a graph, right? But so something about this is that if I didn't see this table here, I wouldn't be able to tell what's going on in this graph because there are no labels. So in science fair, the standard is always label everything. Because you should be able to kind of tell your whole project through graphs and visuals, and labeling is essential. So here you're going to put an axis title. We need axis titles for both axes, as well as a chart title and a legend. So this is the minimum usually for any type of project. So here the chart title will be something like bacterial growth over time. You can also put this in sentence case, like condition 2 decreases over time, well, condition 1 increases over time, something like that. All right, so this axis title should be growth, growth of my bacteria. I think in this case it's going to be millimeters squared. If I'm doing it like over a plate, you can imagine a plate, you measuring the area of bacteria over a plate. So make sure to always put in your units. And then on the bottom, this axis will be time in hours. Okay, great. So this is the basic kind of graph. Everyone should be able to make a graph like this, and this is the standard at the fair. Something else. So let's go to looking at the actual axes. So here we've got a lot of white space here. So maybe we can start maybe around like 9. So the chart option, if you go to chart options and then horizontal value axis, and then click on this option right here, the one that looks like bars. You can go to axes options and you can bind the axes. So here the minimum is 0. Maybe if I make the minimum like say 8, and you press enter, it'll shift it over and then you see it starts at 8. So I just want to do that so I can kind of see it a little better. And maybe at the top we'll have like 35-ish. Yeah. So this is just so I can see it a little better. You don't have to do this, but it's kind of nice to put it into context. Okay, so that's how you limit it. And then you can do the same with the y-axis, but here the y-axes look pretty okay to me. Okay, next what we're going to do is we're going to do a linear regression. So what that means is that we're going to basically kind of try to draw a line of best fit through these axes, through these data points, and try to see like what is a line that can model this kind of these conditions. So you can go here to adding chart elements, this plus sign, and then you're going to go to trend line. and you can check the trend line, and you can add a trend line based on condition 1, as well as a trend line. You click the arrow, more options, and add a trend line on condition 2. Awesome. So you can see that the orange trend line is here, and then the blue trend line is here, and you can edit them more on the side here on this bar. So there are a lot of options. You can do a lot of things with these trend lines, but the basic ones are pretty good. If you click this thing that looks like the bars, it kind of goes into the technical details. So for example, if you have like data that looks more exponential, you can go for an exponential graph like this. But this is really linear, so we're going to keep it linear. But you can do a lot of different things, as you can see. And so in addition to a trend line, something that you should always accompany with the trend line is displaying an R-squared value. So an R-squared value is basically a value that kind of tells how good your trend line is. What it does is that, this is for condition 2. So I'm going to move that back over to the orange one so that we can tell that this is for condition 2. So the R-squared value tells you how well your trend line is fitting the data. It's basically kind of a measure of like how close is your trend line, your line, to all these dots. How well does it fit it? So when you're talking about this to a judge, you can say that this linear trend line right here for condition 2 fits the data really well because the R-squared value is really close to 1. So it's 0.9669. That's a really high R-squared value. And the closer an R-squared value is to 1, the better it fits the data. And then the closer it is to 0, the worse it fits the data. So this is for condition 2. You can kind of, if you hover over, you can see series condition 2, trendline equation 1. I want an R-squared value for the first trend line, so I'll go down to here, and yeah, I want an R-squared value here. And you should kind of move them so that you can easily tell which trend line the R-squared value is referring to. And so they're both pretty good fits, so that's really nice. Awesome. So that's a little bit more professional, kind of a step up. So the next thing we're going to do is we're going to add some error bars. So it's another chart element, so we're going to add a chart element, go to the plus sign again, and check error bars. So when you first check this, there's a lot of stuff going on, but we'll fix that in a second. So you've got your Y error bars and you've got your X error bars. In this case, there isn't really a lot of error in time because you should be more or less pretty exact with time. So usually we don't have like an X error bar for time unless for some reason there may be some error, then it might be good to represent that. More often we're interested in the error in your measurement, the Y values, right? So the growth, we're interested in how much error is there in your growth measurements, because that's the dependent variable we're measuring here. So if we go back to this bar over here, we can do some more things with the error bars. So condition 1, Y error bars, right? So they're highlighted. Cool, you can do some kind of customization things here that I'm not gonna go over. And then if we go back to the bars here, we want them in both directions. But here, this is standard error. You can also do percentages like 5%, or like say like 10%. So that's pretty interesting, right? But in addition, let's say that these points right here for condition 1 and condition 2 are some averages. Let's say you had like 5 petri dishes and then you were averaging out the areas. If you're averaging out the areas, you're likely to have a standard deviation, which you can see here. If I can unhide these. So, sorry. So here's standard deviation 1 and standard deviation 2 that I had hidden. But basically, these are just some values that can kind of tell you about how deviatory was your data from your average. So like in this value, 185, there's like a standard deviation of maybe like 34 millimeters squared. So a lot of people are interested in that kind of data because it can tell you how good of a representation is this point for all the petri dishes that were in this measurement, right? So what you can do if you don't want a percentage or any of these values, you can do something called custom. And so this is something specific to Excel. I don't think you can actually do this in Google Sheets. So Excel is a little bit more flexible like that. So you go to custom error bars, delete this and highlight this for positive. And so it should be a sequence that corresponds to each of the values here. So there's my positive error value, and then my negative one is going to be the same, and that just refers to the ones on the top and then the ones on the bottom. Okay, and so here you can see it's kind of slight, but the error bars will actually vary based on the standard deviation, because the standard deviation for all of these points isn't actually going to be the same. So yeah, I'm going to keep, or I can show you how to do that with condition 2 as well. But so here we do condition 2, custom, specify value. So condition 2, I have the standard deviations right here. And then the negative one is the same. That just refers to top and bottom, as I just said. And it'll look like this. Okay, awesome. So there isn't too much of a standard deviation. Sometimes people use standard deviation as the kind of marker for if your data actually is like the same or different if the bars overlap. So that's something to note. Okay, cool. So now we've got a graph with some error bars and trend lines, so it's looking pretty good. The last thing that I'm going to show you how to do is use some equations to calculate a p-value. So I'm not going to go into the details of what exactly a p-value is. You can watch our other recordings for that. But a p-value is actually a value that can tell you if your data is statistically significant from each other. It's like, for example, if I say condition 1 is one group and condition is another group, my p-value can tell me if condition 1 is statistically different enough to be considered a different group from condition 2. So this can be really useful when you're trying to kind of define your results. You can say that like this result is actually different because it has a very low p-value. And so yeah, all the details on what exactly that means is in our previous presentation. Okay, so here we're going to put an equal sign, and then we're going to put t-test. So students t-test is the formal name for this type of statistical analysis, and it produces a p-value, which I'll explain after we calculate it. So your first array is going to be condition 1. You'll put a comma to separate them. Your second array is condition 2. And then next it's going to ask about something called tails. I'm not going to go into the detail of what that means, but most students will have a two-tailed distribution. And that has to do with the data that you have. So most students will use two-tailed distributions. And then we're going to say it's paired. Okay, so we come up with this p-value. And so how do I actually interpret this, right? So what a p-value does is that the definition of a p-value is that it's the probability that your data ended up the way it is, like completely randomly. Like they're actually, like if I just labeled this condition 2, but actually that this data was from condition 1, and it just happened to be that condition 2 is like decreases over time while condition 1 increases over time, just completely randomly. And so the kind of goal here is that you want to kind of have a low p-value. Most people say that below 5%, so 0.05 is the standard. And so here I have a p-value of 0.012, which is definitely below 0.5, which means that there's a very low probability that I got this data just because by coincidence, that coincidentally the data looks like this. And so that's kind of a good way to prove that your data is statistically significant. And we can talk more, and we talk more about how exactly to explain that to a judge in our previous recording. Okay, so now you know how to make a graph look like this. Not every project needs all these things, although I think that this will be really useful to a lot of students in the fair, and it really gives you kind of an advantage. Make sure to review carefully and search on the internet to make sure that you understand each of these and know how to explain what they mean, like what does a trend line actually mean, why is it useful, etc. And so yeah, we hope you really enjoyed this video. If you have any further questions, you can comment on this video or email us in the link in the description. And good luck with science fair.